Today I'm going to be talking about isotopes and ions. So an isotope is an atom of an element that has a different number of neutrons than the normal element. There's a few different ways to write an isotope in its form, and these are two examples. In the first example, you just have the name of the element, and then this 32 represents the new mass. Because the number of neutrons is different, the isotope will have a different mass than the normal atom. Same thing over here, this 32 represents the mass. There's a few other things that you might see on this type of isotope. It might have the number of protons down here. So the number of protons for sulfur is 16. So you might see that, and that just represents the atomic number or the number of protons. So that's the number that you would see on the periodic table. That 16 there represents the number of protons, and then this is the average atomic mass, which we'll talk about later. You might also see a charge up here in the right-hand corner, which you will also see a little bit later in this video. So, if I asked you to figure out a few different things about isotopes, there's a lot of information that you could tell me just from this symbol. So the first thing you could figure out is the atomic number or the number of protons. If it wasn't included, like it is right there, all you have to do is look at the element card on the periodic table. The atomic number for an element is never going to change, nor will the number of protons. So since this element is sulfur, sulfur always has 16 protons, never ever going to change, always going to be the same. Then you have the mass. That is not the mass from the periodic table, so we're not going to use this number right here because we're talking about the mass of the isotope. So what we want is the mass that's up here. So the mass is 32, and if it was in this form, we would use the 32 like it is right there. Then the number of neutrons. To get the number of neutrons, you take the mass and you subtract the number of protons. So mass minus protons, which means that I'll do 32 minus 16, which will give me 16 neutrons. And then you need the number of electrons. As long as there is no charge, the number of electrons will be the same as the number of protons. So I'll write that down. No charge, same as protons. So since I had 16 protons up here, that gives me 16 electrons down here. That will be different when there is a charge involved. So we'll do another example. Now I'm going to give you an atom that has 12 protons and 12 neutrons, and I want you to see if you can figure out what the isotope form is. So the first thing that you'll notice is the protons. Protons are going to tell us what element we have. So if I go to the periodic table, the element that has 12 protons is going to be magnesium. So if I'm writing this in element form, Mg would be my symbol. And then I'm going to need to find the mass. It's not going to necessarily be the mass that's right here. I'm going to have to calculate it. And to get the mass, I will take the number of protons and I will add the number of neutrons. So 12 protons plus 12 neutrons will give me a mass of 24 AMUs. So then my mass would go up here in the top left-hand corner. Then the next thing is another example, and this time it's going to be with phosphorus, and I'm telling you that it has 17 neutrons. So before we can really begin, we can go ahead and write our symbol, but we need to know how many protons phosphorus has to find the atomic mass. So I'll look on the periodic table. Phosphorus is number 15, which means that I have 15 protons. I'll add that to my number of neutrons, which the problem told me was 17. And 17 plus 15 gives me 32, or gives me my mass. So my mass is going to go up here, and that is the isotope form for phosphorus 32. Okay, so that's isotopes.